Welcome to Section 3, Video 3, Creating the Player Character's Code, Part 3, Basic Movement. In this video, we are going to set up our inputs to connect to our player and set up our visual aspects of movement. First, we are going to set up our visual asset by going to the Content Browser under First Person, Animations, and open our First Person Anim BP. This is an animation blueprint that allows us to code specific animations based on our code's values. Drag out of try get pawn over and enter in cast to player character BP. Connect the execution pin on the left to is moving execution pin on the right, and connect the execution pin on the right, not from cast failed, to sprint check execution pin. Out of this, we're going to get our variable for get is sprinting. Connect those two for is sprinting and sprint check, and we now have set up our animation blueprint to connect to our player character's movement. Select save and then compile. Let's jump into our player character blueprint and add that visual asset to it by going to FP Mesh. Under the skeletal mesh, select SK Mannequin Arms, and for our anim class, we will be using the first person anim BP. As you can tell, it is offset greatly, so we're going to fix that by going to Location in the Z and change it to -160. For our rotation, we will be setting the X value to 5 and our Z to -15. Select Save and then compile, and we have set up our asset. Let's open our C++ class for our player character. Under the public category, we are going to add in 3 float values or variables. These are going to be setting up our player's camera movement rate and setting up our sprint speed variable for future use. Here we are creating our functions for moving left and right using the axis values that we created previously as our scalar value. This applies for lookup and turn at rate, but for our camera instead of using actual movement. Here we are setting up our camera's min and max pitch values. We won't be needing this for our movement speed because the camera is not controlled by the character movement component, which will handle that for us. Here we are setting up our previous walk speed variable for future use under the private category because we won't be needing it outside of this C++ class. Let's jump into our source file, and in the constructor, we are going to set up our default values for our camera movement and our camera's pitch, min, and max values, as well as the default sprint speed. Let's go back to our header file and create our definitions for move forward, move right, look up at rate, and turn at rate. Now that we've done this, let's go into our source file and add some definitions to that code. Select Save All, and in the turn at rate function, we will add in a already created function that is created within all pawns, and what we are doing is affecting our control rotation's yaw rotation by adding some math, which what we are doing is incrementing very slowly in the yaw direction every frame by using the world's delta seconds by the amount that we would like, which is our base turn rate. Our rate is actually our scalar value from our axis value that will be either -1, 0, or 1. In the lookup at rate, we've added a more complicated version of what we were doing in the turn at rate. Here we are checking to see if our spring arm component reference is valid by putting it within a if statement, and then we are checking the initial rotation and saving that for our frame. This is all happening within one single frame. Then we are saving the clamped pitch of that saved rotation if we were to rotate it normally. Then we are setting our rotation that we saved for its pitch to be the clamped version. And then we are applying our new clamped rotation to our spring arm. We do this so we can independently rotate the pitch of the spring arm while constraining it to our min and max values. You may notice some variables within this function. These are temporary variables that get deleted after it ends at the end of the function with the curly braces. We are also using the keyword const for constant so that the compiler will load this faster in the computer's memory and it is faster that we didn't use this. We are also using the keyword constant so that the compiler will load this faster in the computer's memory, and if it is faster, then we won't be using const otherwise. We are using the keyword const so that the compiler will load this faster in the computer's memory, and it is faster than if we didn't use const. But we can only use const when we don't plan on changing that value anymore or anywhere else in this function. In the moveRight function, we are telling our character component to move us in the direction that we would want at the rate that we would want. In the case of our direction, it is the right direction of this actor, and in the case of our rate, we are using our scalar value. We are also checking if our button is being pressed by checking if our scalar does not equal 0. If it does, then we aren't moving and there's no point in continuing. Here we are doing the same thing as we did with the function moveRight, except with the forward vector instead of the right vector. In our setup player input component, after the check function or macro, here we are binding our axis values as well as binding our action for jump to an already created function within the character class for jumping. For binding an action or axis, we require the name of the binding, and it is case sensitive. For the actions, we need to specify whether or not it is being pressed or released. And then for both, we also need to supply an object, which in this case it is this class and this object to bind it to, and then the function within the object to bind it to. It doesn't matter whether or not it inherits through it, as long as it is somewhere within the inheritance of this object. These functions are bound when the engine is initialized and happens only once. Now let's go into our engine and compile. Now that our engine has finished compiling, let's go to Blueprints and drag our player character BP into the level and scroll down in the Details panel to the very bottom, and under Auto Possess Player in the Pawn category, let's change Disable to Player 0. Then select Play, and as we move our mouse around, we can look around. As you can see, our thumb in our hand are casting a shadow, as well as our arms. And if we press W, we move forward, A moves left, and D moves right, because A is a negative value of D, so it'll just move in the opposite direction, and this works the same with the S key. This also works with the arrow keys. And if we press the space bar, we jump. Hit the escape key to stop playing. In the next video, we will be creating the player character's code part 4, sprinting.